Hello, in today's video lesson we are going to talk about different types of numbers. And another word for different types of numbers is the word set. And this links to the Swedish curriculum in that it says that you should expand your knowledge of the number series of numbers by introducing the concept of complex numbers when solving quadratic equations or when solving equations. So let's start with, before we go into complex numbers, let's start with a revision of what you hopefully should know from before. So you might see groups of numbers described using what's called set notation. And set notation involves these kind of curly brackets. And that basically means that you have a family of numbers contained within this set. So let's start with the most basic set of numbers, n. N is the set of what we call natural numbers. And they're used for counting things. So in the set of natural numbers we have 0, 1, 2, 3, 4, and so on, but no negative numbers and only whole numbers, you see. In order to count negative numbers, or to do the operation, for example, 6 minus 8, which gives us a negative number answer, we have to introduce the set capital Z, which is what's called the set of whole numbers. But the whole numbers can be positive or negative. So, for example, it's any numbers less than minus 4, or whole numbers rather, minus 3, minus 2, minus 1, 0, and then going up. 1, 2, 3, 4, and so on. However, we can't, with these two sets, describe a number like 2/3, which is a fraction. In order to describe these numbers, we have a new set called capital Q, which is the set of rational numbers. I.e., for example, 2/3, 1/3, minus 1/2, etc. And the way we define Q is the set of numbers A divided by B, where both A and B are whole numbers. However, with these three sets, we can't describe all the numbers that you know so far. For example, what about the number the square root of 2? Can this be written as a fraction? Well, the answer is no. Also, the number pi cannot be written as a fraction. These are what we call irrational numbers. and they can't be written as some number a divided by another number b. Therefore, we introduce another set called R, which is the set of all, it's called the set of real numbers. And it's the set of all rational, so the set Q, all the numbers in the set Q all rational numbers and irrational numbers. But they have to be real, what they call real numbers. And the opposite, or an extension of the real numbers, is the so-called complex numbers, which we'll talk about in another slide. Let's just take a new slide. So all rational numbers that we know can be placed on the number line. So let's draw a very crude number line. We have 0 in the middle, 1, 2, 3, 4 positive numbers on the right and negative numbers on the left. And for example, I could place, here's the number 1, for example, here's the number 2, in between 1 and 0 is the number 1/2, the number negative 3/2 is here, the number square root of 2 is roughly here, roughly equal to 1.4, and pi is also a irrational number, but it can be placed on the number line. It's roughly 3.14. If we like, we can draw the sets of natural whole numbers, rational and real numbers, in this kind of set notation. So this is so if we think of the set of natural numbers, we have, for example, 0, 1, 2, and 3. They're contained in the set of natural numbers. If we expand this set, we can write the set Z of whole numbers, which also contains the set of natural numbers like this. Therefore, Z contains 0, 1, 2, and 3, but it also contains, for example, -1, -2, and -3, which n doesn't contain. But n is what's called a subset of Z. We can then expand our picture by including the set of rational numbers Q. So in Q I can write, for example, 1/2, 1/3, 1/4, -1/2, -1/3, -1/4. We can also write here, for example, -1 divided by 1, which is the same as 1, but it can this set is also or the set Z is a subset of Q. And then again, expanding our set family one more time, we can include all of these other sets within the bigger set R of real numbers, which also contains pi and square root of 2, for example, which cannot be written as a fraction. However, we've got a problem because up to now we've not got a solution to this equation. Solve x squared equals minus 1. Up to now we've had to say this equation has no real solutions. However, in order to get around this problem, a new number is introduced, namely I, and I is defined as, or the square of this number I is equal to negative 1. And we call I the imaginary unit. And it's defined by the square of I being the negative 1. This is a rather strange number which doesn't have to have any practical use, but it actually turns out that it does. But now we have a tool whereby we can solve these types of equations, these types of quadratic equations. So now, if we have x squared is equal to minus 1, then since we can replace negative 1 by I squared, and we get x squared is equal to I squared, then we take square roots on both sides, we get x equals to plus or minus I. And this is the solution of the equation, and this is the solution is what's called a complex number. And generally, a complex number z can be written as z is equal to a plus b times I. So we have what's called a is what's called the real part, and b times I is what's called the imaginary part. A and B also have to write are real numbers. So let's do an example. Let's take an example from here. Solve x squared minus 2x plus 5. Equals 0. We're going to solve this quadratic equation. So let's use the formula. We get x equals minus a half the x coefficient, which gives me plus 1, plus or minus the square root of half the x coefficient squared, which is 1, minus the constant term, which is 5. This gives me x is equal to 1 plus or minus the square root of 1 minus 5. 1, which is 1 plus or minus the square root of negative 4. And by factorising out negative 1 from this, I get x equals 1 plus or minus the square root of 4 multiplied by negative 1. Using our new definition or new number, I squared equals minus 1, I can rewrite this plus or minus the square root of 4 multiplied by the square root of I squared. Remember, if you have a product under a square root sign, you can write it as the product of, or the square root of the one thing multiplied by the square root of the other thing. So here I have x equals 1 plus or minus the square root of 4, which is 2, and the square root of I squared is just I. So we have an answer, but it's not a real number answer, it's a complex number answer. And you can either leave your answer like this and write x1 is equal to 1 plus 2i, or an x2 is equal to 1 minus 2i. It's also common to represent this on what's called the an Argand diagram, or the complex plane. So Argand, A-R-G-A-N-D diagram, and it's basically a bit like the Cartesian coordinate system, except we have two axes. We don't have an x and y axis anymore. We have a real axis, RE, which is called the real axis, and we have an imaginary axis, IM, which is the so this is 1, 2, 3, 4. This is our real number axis scale, and this is going to be our imaginary part. So this number, the first solution, 1 plus 2i, is represented by going along 1 on the real axis and up 2 on the imaginary axis. This is 1 plus 2i. The second solution, 1 minus 2i, is still going 1 along on the real axis, but I have to go down 2 on the imaginary axis. This is the second one, 1 minus 2i. So the Argand diagram is used to visually represent pairs of, or complex numbers as a pair of numbers on this so-called Argand diagram.